We're going ahead with the unit 1 on the chapter on concrete. So far what we have covered are the ingredients in concrete, right? The next subtopic would be manufacturing manufacturing of the concrete. So these are the processes which are involved in various steps in manufacturing of the concrete. First will be batching of ingredients. Now batching can be weigh batching as well as volume batching. What is actually accurate is weigh batching, however what is mostly followed on a site is volume batching. What do you mean by volume batching? When you mix the ingredients like cement and aggregates, you mix them in terms of volume. Okay, you do not weigh the amount of cement, you do not weigh the amount of sand and the aggregates. Instead, you directly take it in terms of, let's say, a bucket, okay, and that's how you mix it. The next step is mixing of ingredients. Okay, over here in the image, what you can see is volume batching. Okay, now here, mixing of ingredients can be done by hand mixing as well as machine mixing. Okay. If you want to go for better quality or better supervision or a work which requires better quality, then you should go for something called machine mixing. Hand mixing is usually adopted for small scale works. Okay. Now what you can see here is hand mixing going on this side. This is using a mixer. Now you people must have seen those huge RMC mixers. Okay. These are what are being presently used for major scale works. Right. The third step is transportation of concrete. Transportation can be in motor pans, it can be in wheelbarrow. Okay, this is a wheelbarrow, what you can see. Then hand carts or concrete pumps. Okay. Now, one important thing is when you are transporting concrete, the time that is lapsing between the mixing and placement into the formwork should be minimum, okay, so as to not cause setting of cement in the concrete. And the next one is placing of concrete. A thumb rule or a normal guidelines while placing the concrete is it should not be dropped from a height of more than 1 meter. Okay. Then while placing the concrete in position of formwork, first and foremost, let's see if you are using the concrete with the steel, that is you are placing RCC. Okay. One important thing is when you drop the concrete inside the reinforcement cage, you have to take care that reinforcements should not be disturbed. Okay, there should be proper cover on all the sides of the reinforcements. Okay. Then compaction. Compaction can be carried out again by hand or using machines. These machines are called vibrators. When you use vibrators, most important thing that you need to take care of is that aggregates should not segregate. What is segregation? When all the coarse aggregates are coming together and the cement grout comes on one side, that particular thing is called segregation. Now, how will you know that your material has segregated or your aggregates have moved at one side and your concrete is not any more homogeneous? See, if you might have seen it on a lot of surfaces, you will, after deshuttering, that is after hardening, when the formwork is removed, if you see a knife cut edge on one side and bang opposite, on the opposite face, if you see the gravel, then the concrete is segregated. Such kind of concrete will not give you the adequate strength. If you have designed it for a particular value, the actual strength achieved by that member will be way much lesser. Okay. So what you can see here, this is compaction by simple hand tamping. Okay, this is compaction using a needle vibrator. What you can see here is it's like a small pipe and there are vibrations induced in this pipe. So what does this do? It removes the air from the voids. And when the air is removed, the concrete obviously will become much more dense. Okay. Then the next is curing of concrete. What is curing? Curing is a process of maintaining moisture content in concrete. Why do we need the moisture content in concrete? Because cement when mixed with water is an exothermic reaction. Okay, heat will be liberated. You need the surface to be constantly wet. Otherwise, there are cracks which are likely to occur. Okay, curing can be carried out by various ways. You can do ponding with water. You can cover concrete with wet straw or any jute bag, or you can just use sprinkling of water. So what you can see, this is a sunk slab. What is a sunk slab? When the level of this slab is lower than the adjacent one, that type of slab is called sunk slab. In case of sunk slab, you can do curing by ponding. Right? You can just store water in it. Right? Eventually, you have to remove it. Then, if it's a inclined surface, like if it's a sloping roof, on that obviously ponding is not possible. So you could do just covering by jute bags. Okay. Then here, what is happening? This is a column. So what they have done, they have covered the column with a jute bag and then they are spraying it intermittently so that the jute bags remain moist, remain wet. Okay. Then the next type of concrete that is there is RCC. What is RCC? RCC is concrete reinforced with steel. Okay, now why steel? Why only steel? So there are different materials which can be used. The reason we are using steel is relatively better in tensile strength in comparison to concrete. So RCC is basically a composite material. And when you have a composite material, there are multiple drawbacks, multiple problems that can arise with composite material. First and foremost is any material has a shrinking and expanding thermal coefficient, okay, that governs the shrinking and expansion at different temperatures. So when you are going to mix two materials, what is most important is that thermal coefficient have to be similar. If it is not, now you people must have seen fine hairline cracks where the beam ends, okay, and a beam which is placed over the wall. At the interface of beam and wall, you will always see cracks. Why so? The reason is your beam is made of concrete, RCC. It has a different thermal expansion coefficient. And your walls will be made out of bricks or laterite. At that point, the moment a structure becomes slightly old, let's say it has around 1 to 3 years have elapsed, you will see hairline cracks where the beam ends, where it rests on the wall. The reason being, both have different thermal coefficients. Both will expand and contract at different temperatures and at different magnitude. So there will always be such kind of cracks. Now imagine if there are two materials inside one material. Let's say in case of RCC, you have concrete and steel. Okay, so both will expand and contract at different temperatures. Then how can we use something like this? How can such material be used for building construction? Why we can use this? Because the thermal coefficient for expansion of steel and concrete is almost similar. That's the reason we go for this. Okay, concrete will not expand at a different rate in comparison with steel. That is the reason we can combine them. Okay. Also, they are complementing each other in terms of properties. The the steel that is used for reinforcement is called rebar, reinforcement bar. Okay. Further, if you want to go into the depth of designing of RCC, there is a IS code dedicated for RCC, and that is IS code 562000. Reinforced cement concrete is primarily used as a structural member. Why it is used as a structural member? Because it is very high in strength. You can alter its strength as per your requirement. Okay. RCC starts from M15. Anything less than M15 you cannot go for RCC. What is M15 and what is M20? I will deviate back to another topic now just to explain on what are grades. Grade of concrete is basically the strength that it will have at 28 days. So can I call a concrete M20, M30? These are the names, okay? Just as we have names, if I have to identify what type of concrete it is, I will have this particular way of naming it, M20, M30. What is M? M stands for mix. And 20 stands for 28 days characteristic compressive strength of 150 mm by 150 mm by 150 mm cubes in Newton per mm square. So this 20 is 20 Newton per mm square, which is the compressive strength of the concrete of this dimension, a cube of this dimension, at the end of 28 days. So you have to cure it for 28 days. You remove it out after curing it for 28 days, let it dry for 24 hours, and then you test it in a compression testing machine. That is called grade of concrete. Okay. The next is water cementation. This is perhaps the most important thing that governs the properties of cement. Okay. The ratio of the amount of water to the amount of cement by weight. This is most important. By weight is called water cementation. The strength and the quality of the concrete primarily depends on water cementation. I'm purposely going very slow on this particular topic because this is probably one of the most important things that govern the strength of concrete. Why we need strict site supervision and control is going on is because you slightly also alter the amount of water, which is very much likely because more the water, more easy it is to mix. You see, if you are making a chapati dough and you add less water, what happens? The dough becomes very stiff. Okay, you won't be able to make chapatis very easily. You have to apply more pressure. Similar thing will happen in case of concrete also. And those people who are working with concrete are middle class people. They are working in hot sun. We have to understand their difficulties also. So it is natural tendency. You or me also will do the same thing. If I'm finding it very difficult to mix, I may add a little bit of water. Because I don't know what are the final repercussions, what are the consequences of adding excess water. Water in the concrete has to perform two primary functions. The first one is it enters into a chemical action with cement, which causes the setting and hardening of concrete. Water lubricates the aggregates and it facilitates the passage of cement through the voids of aggregates. See, I've been always telling you, concrete is a rock solid mass, so major volume inside a concrete mass will be occupied by gravels. Idea behind adding these fine aggregates is it should occupy the voids created by gravels. Otherwise, the entire thing could be gravelly. But since there are voids, those voids cannot be completely occupied by cement ground. You need to add sand. Sand is also having very high compressive strength. So we add sand so that it occupies the voids inside the gravel, and the cement grout is eventually supposed to occupy the voids which are left after the sand has occupied the voids inside gravel. So water is required such that this grout easily enters. Little more water. See, for cement and water to enter the grouts, it has to be fluid. It has to be fluid. So that is also another function which is performed by water. So this means that water makes concrete workable. This term is very important. Workable means what? Easy to handle. Okay. The quantity of water is usually expressed in liters per bag of cement. 1 liter of water is equal to 1 kg of water, right? Volume and weight of water is 1:1. That's why we say specific gravity of water is 1. Right? Quantity of water used should be minimum. Excess water occupies space in concrete and eventually evaporates. So once it evaporates, voids are created in the concrete. The strength and durability of concrete gets affected. Maximum water cement ratio is limited to 0.45 by IS code for severe conditions of exposure. And you all should understand that Goa falls in severe conditions of exposure. That's the reason, as per the IS, the minimum grade of concrete for severe exposure conditions, if I'm not mistaken, is M35. And still in Goa, people are using M20 and M25. Even in the interiors of Goa, you should not go for anything less than M30, and the reason being, Goa is humid for entire year. It is not that we have high humidity only in monsoons. It is Goa has a very good network of rivers. Okay, everywhere the humidity is high.